Hello everyone, and welcome to this workshop about template injection. Before I get started, I just want to do a little check in the room. Does anyone is familiar with template injection already? Already exploited? Only one people? Okay, so I will need to be a little more thorough on every explanation. So to follow along, I've built some Dockers for you. So you will need to download them from, you can just wget them from bi.tk/docker compose.yaml. Let's yeah, sure. Open the internet sign and just run docker compose up. Is the URL. Is it big enough? Yeah. And when you have your Docker Compose file, you can just run Docker Compose up, and you will be able to access 4 different websites. And we'll start with the first one. So this is the website we are going to attack today. It's a simple Python application. Let me zoom in a bit more. Is it big enough? Okay. So it's a little Python application when you can submit paste bin, basically. So I can put a test, hello, in the box. And my secret I want to save, it's like, oh, this is a secret. So I can save some secret on this website. I got an URL with a key, and everything is encrypted client side, so it's end-to-end encryption. And I can share this link with other people. But what we are trying to do is actually exploit this website. In this website, there is a contact page when you can submit an email and a message to the admin. And after some digging, this is something I found in Bug Bounty, basically. There is an email, you can submit your email. Here, BitK at YesWeHack. If I send the email, if I try to send the mail to the admin, but actually there is a template injection in the email field. It's not visible there, but I will show you in a bit. So what is template injection for? Because a lot of you don't know a lot about template injection, I will show you another website. So you can access this one to follow along. It's SSTI. Let me put it in bigger. So what is template injection? In a lot of websites, when the developer are building the website, they use some templates to provide a page. For example, I can do a basic h1 tag and hello and the name of the user. And here in double brackets, you can put some variables. So if I put a number, it will just render my title with a number. But if I can do some operation and stuff like that. But usually the user is never supposed to provide you with a template. Only the developers are writing the template, and the user are supposed to provide the variable that will get into the template, like a name or something. But sometimes you can manage to write template, and this is where the issue come in. So with template injection, you got basically access, you can write some Python code, and it will get executed. Like here, I just did a simple addition. But if I want to do something more nasty, like calling a command, it's doable. And in a lot of, how to say it, like, so this is Python code, but it's not exactly Python code. Here we are running Jinja code, and Jinja code is not Python. If I do, for example, print, and I try to run this, the print function is undefined. We are in the sandbox. We don't have access to all the Python we would like to use. So the first step first thing we're gonna do is write full Python code. So how are we able to recover, to get access to all the Python code we want to execute? One thing is nice is we can do introspection here. For example, if I put an empty list, and I try to access like a class variable, I can dig inside every object inside Python. So this is cool, but this is not all we want. What I would really want to do is something like import subprocess and do a subprocess.check output, I don't know, ID or some command like this. But if I try to run this code, it's not valid. It's not valid Jinja code. You cannot do that. So the first thing we want to do is recover all the built-ins from Python to be able to execute arbitrary code. And there is an easy way to do that. So in Jinja, if you put a random variable here, I will just get an empty string. Because in Jinja, all variables are just replaced by the undefined variable. So if I look at the class of this undefined thing, I will remove the H1 because it's too big. Yeah, it's treatable. So you got this undefined class. So this is a bit weird, but that means I can use any variable and look at it. If I look at the init function, this is a bone method init of the undefined class. But in Python, since Python 3.10, there is actually a hidden thing attached to every function of every function from every class. If I try to access built-ins, I will get access to all the built-ins from Python, and from here I can call I can access other function like the eval function or the exec function. And with exec, I can now import any Python code I want. So if I do import subprocess, this is doable here. The issue with that, here we can now run arbitrary Python code inside our template. The problem with that is we don't have the output anymore because exec is not returning any value. It's just running the code. And if I try to do a print, like print 42, the print run, but it's not showing here. Why? Because it's actually just printing to stdout. Oh, let me just flush. Here, I got the output here. But this is useless if you're an attacker because you don't have access to the console log. So the next thing we want to do is manage to change this blind injection into a non-blind injection. And there is an easy way to do that. Because we are running Python code, in Python nothing is private, everything is public, and you get access to some nice helper function from Flask. Here, I can import from Flask, import current app. And what current app is just a reference to the actual application running. But you can also import some nice helper function called after this request. This function is a function that takes a function as an input, so you can use it as a decorator. So I can say, okay, after this request, run this function. So let's call it hook. Let's take any number of arguments. We don't really care about them. Quarks. And here, we will be able to just replace the expected output of the function. So here, I will import from Flask the make response function. I will create a response. And if I try to run the code, okay. I'm still in double quotes over there, so I need to use single quotes here. This will happen a lot during the talk. And if I run this, I got the hello back. So here in my Python code, I'm able to run completely arbitrary Python code and be able to get the output. This is very useful if you are doing some exploitation and you have like blind injection. This makes the whole injection not blind anymore. Even if the return value is not shown at all, like here in this example, here there is template injection in the email field, but I get no output. But if I use this kind of payload, which is a bit too big for this, but it's doable, you will be able to get the output. So this is the basics of template injection, and we will try to write some software to exploit the other website. So let's start with that. Okay, so let's look what the request look like when we send the message. So when we send, it's just a simple post request. Is it readable? Yeah. Just a simple post request with some data. So let's build something like that so we can be able to exploit it later. So a new file, I'll call it exploit.py. I will import request. Let me zoom in a bit. Okay. So let's write a function def send payload with our payload. And we will do request.post. The URL is this one. Copy URL. Localhost API contact. Okay. And the data is mail with my payload and the message, which I don't really care about. And let's just return the actual HTML code at the text. So now if I try to send the payload, let's try test and print the output. I can close this, I think. Okay, connection error. What is happening? The port is good. Why is not? Why? With API contact. This is weird. Why is my request not working? Python. Oh, okay. Why it's not? URL is wrong? I think it's fine, right? I mean, if I just try to this, then okay. No, the URL is actually fine. And if I try to do like headers, okay. So I managed to do it. I just tricked the server into doing that. And this is the actual response I'm expecting or no? So let's send an email, send, post, contact, request, response is an email was sent to the admin. So something went wrong. Something went wrong. And the payload is test message. Why is it not sending the request? Test. I don't know what's happening with my Python package, but data is good. I don't get what it's not. I'm sorry for the delay. Why is something went wrong? Let me just stop my antivirus. It's probably messing stuff. Okay. And okay, it should be better. Look, I put that over there. I still got something went wrong, but at least it's working now. And what I'm missing in the request post? Oh, it's JSON data. Okay, we're back on track. Okay, so we can just send basic email like that, and now we will try to do our exploit. So this is we'll take the exploit I wrote earlier, just to test it. So this is the whole payload. So because I don't want to escape this every time I do my payload, I will write a small stager. What I can do is, inside of my mail, I will put the beginning of the attack. So first I want to recover the built-ins and run the code here. But because I don't want to escape my code all the time, what I will do is I will access the actual request and put an extra parameter. Let me show what I mean. Here, if you look at Flask, from Flask you can import the current request by just importing a request. And in a request, you can access all the parameters. Let me show you. For example, if I do dir of request.args. Oh, not request.args, it's request. Oh yeah. In my request, if I want to access other parameter, I can just access request.getJSON. So what I will do is I will send an extra parameter that is not actually used by the application with my payload. So here, what I will execute is I will do exec. I need my quotes. I will do from Flask import request, but also after this request, I will redefine my after this request hook. Def hook with any argument. I don't really care about that. Usually you get a single argument which is the original response, but we don't want the response now. I will import request here, actually. Import request. Why importing this here is because the code is run in a weird state, and sometimes you don't have access to the thing you imported before, so imported this inside the function make it way easier. And here I will just exec the request that get JSON, and this is the object of my request, and I will access the payload thing I will create in a sec. Exec payload. I got a lot of codes, and also what I will do is I will redefine the print function, because if I try to print, I showed you before, it will just print to std out, which is useless for me. So let's make a small print function, and let's build a buffer also, buff, which is an empty string. Print will take any amount of argument, and we will do buff. Just print something, and when so okay, let's just check everything. So the mail is not all of that. So it will recover the built-in, get access to exec, hook the current request to execute this code instead. In this code, I will get the request object. In the request object, I will get the form data. With the payload, I will execute it and return everything I put in print. And now I can do my add the payload thing here. Let's see if it works. So payload, and my payload will be just a print test. It probably won't be working the first try, but okay, it didn't work. Why? Because I forgot to put the actual template injection there and there, and something went wrong. So what went wrong? I don't know. Let's try something simpler. Let's just comment this code and write test. Okay, what did I broke? Make response, I didn't import it. Test. Okay. From Flask import this request and to action. Let's go there. Let me try that in the playground. What did I forget? Exec from Flask import after this request, def hook args from Flask import make response, return make response of test. Oh, what is this parenthesis? No, it's fine. Oh yeah. Response. Okay. So now I can run the code, and when I had, this is working, I got my test back. That means here we had like a totally blind template injection. We didn't know what was rendering, but we transform our blind template injection into a non-blind template injection. So this is nice, and if you are doing bug bounty like that, you probably, what you want to do next is just not printing test, because printing test is cool, but it's useless. We will import the subprocess module. And from the subprocess module, we will actually get the checkoutput method. Checkoutput, just take a command, run it, and give you back the output. So make response, we'll do I will rebuild what I did before with the print thingy. So I still have it now. Okay, and make response. Is this running? Something went wrong. I broke everything again. From Flask import request, return make response. Oh. Okay. And here we'll once again get the payload. So the payload is equal to the request get JSON payload. I need to use single quote. If I put payload here, so here you can see I can use extra arguments I have defined there. They are not usually used by the application, but because I got access to the whole request, I can use this. And I will just exec this code. So exec the payload, and I will rebuild my simple print function. Instead of args. Let's put a single and the buffer here. Exec and buff. Something went wrong. What did went wrong? If I just do this. Make response. If I don't exec this. What is the mistake? Okay. Something with my buffer. So anyway, let's continue. So now we can run the code. So let's check what's actually running on the server. So if I try to import, so I said subprocess, from subprocess import check output. Here we can just run a command. So let's run id. I will put shell equal true, so I can just type stuff if I want. And I broke something again. What am I? Oh yeah, the codes. Okay, so I'm running my Python code, but I'm running my code and I see this. And this is what happened to me during a bug bounty, is yes, I got an RCE on a server, which is pretty cool, usually. But I see that I have like a very basic user with low privileges. And if I try to look around, I will see some files, but everything is in read-only. And also, if I look at the application code, check it. Let me open that a little bit more. So I can look at the application code. I see the application is dropping the privileges, so I'm running as nobody. And it's very, very basic stuff. And I can basically do nothing because there is no data on the server. If I try to access the database, let me show you here. So, okay, I get my application. And if I cut the roots.py, so when we save a secret, it's just getting the secret from the request and storing it inside a database. But I don't have access to this database. And anyway, everything is encrypted, as we see before. So I got an SE, but what is the actual impact of this bug? I can do basically nothing. I got no access to the files. I got no access to the data. So yeah, RC, but what's the point? And this is what we are trying to bypass. So what can we do in this situation? So I came across this and I started to think, okay, so I cannot backdoor the Python file because if I try to do it, well, I'm not able to do it because they belong to root and I'm nobody. But it got me thinking, and I started to look at the process running on the Docker. Okay, there is no PS in this one. But what's happening is there is a single process, but the process is running as my user because this is what I get when I try to see who I am. So because my user is running the process, I should be able to access the process memory. And if I'm able to access the process memory, I should be able to find inside the memory the function responsible to make the response. And if I'm able to find this in memory, I should also be able to replace it directly in memory without touching the file system. So how can we do that? Let's continue. To do that, we will look at Flask internal stuff. Oh, I got the thing here, which is quite nice. I got some notes. I will replace this one with that. Yeah, put single quote there and there. And did I broke everything again? From Flask print. Why is it not? So I got this, return, make response. This should be running. Like the JSON payload. Let's try on the playground again. Animated string little. What did I forget? 18. Here? What? Okay. I just need an extra backslash, I think. So, okay. This is what I tried to do before with the print thing. This is made way better. So now I can run just any Python code over there, and I don't need to escape it anymore. And this will be helpful because right now I'm showing you all of this here, and I'm lacking syntax highlighting. So I will just create a new file, which I call payload.py. And we will just read the payload.py file from and submit it. So it's easier to read. So we got this, and the payload will just be open payload.py read. And now if I do just print test, okay, so we can see, we will see a little bit better what we're doing. So okay, I was talking earlier about in-memory attacks. So let's try to do that. One thing is cool in Python is because everything is public, we will be able to access a lot of stuff. So from Flask, we can import the current app. Let's just rename it app so it's shorter. But what I can do is, because I can do whatever I want and the code is running inside the Python process, I can just define a new route if I want. But I can also look at other routes. So let me show you. In Flask, all the routes are stored inside a view function object. So let me show you what I say. So if I try to look what's inside the app, there is a bunch of stuff which is built in from Flask. But the interesting thing is the view function. The view function is actually a dictionary inside Flask that will match every root name to its actual function. The thing we want to do is, because what we want to do is to steal all the secrets from the admin, we will go to the page, so api.save, and we will replace this function. So if I look at this, api.save, this is the actual function that runs when we call the page. Let's keep a copy of this one. So original is this one. So we keep a copy of this function, and we will create a new function to replace it. So let's rename in bad func, or I don't know, malicious func. Let's take any argument and any named argument, because we don't know what the function is supposed to receive. Actually, we know because we look at the source code just before, but most of the time you don't know. And what we will do is we will call the original function with the original arguments and the original named argument, and we can just return that. If we replace, so we have our malicious function, and now here we can just replace the original, the reference to the original function by our fake one. Okay, but here we are just doing what the original is doing. What we want to do is store the password. So the password will be accessible from the request. If we look at the source code, let me comment that for a sec. What's that? Py. That's right. Oh. If we look at the original application, okay, so it's not the code, because of course, if we look at the original application, the secret and the title are getting they receive from the request from JSON. So we'll do the same thing. I'll try to store it. So here I will get my form. So form will be request.getJSON. I will create a temporary database. So let's call it DB, which will be just be an array. And every time we receive a request, what I will do is DB. I will append inside my DB the form, and I will get the secret and the title. So I get the title and form.get secret. So now every time someone submits a new secret to the website, the original function will be called, so everything will be working as like before. It will be invisible for the user, but everything will be stored in this DB object. And what we can do is say, okay, if in the form, if form.get, I don't know, let's hack, if there is a parameter called hack inside of it, instead of calling the original function, I will just return the list of the password I've stored. So I will make a response. And or I can just do print, and I will print the DB. Else, I will return the original. Let's return the DB like that. And now I can replace the original function by mine. And let's just print a message to say it's hooked. Print hook, and here we'll just print malicious func called. Let's do some flushing also, just in case. I don't think I need it. So if I run this code, oh yeah, because I got this after that, so I still do that, but I see the hook in the beginning. And now I think every time I will try to store a secret, everything should be working as usual. So let's test this. So test and secret. I tried to save it and everything broke, so I think I broke my website. No. Yeah, I broke the website. So this is also something I want to show you, is doing this kind of stuff is a lot of fun, but you can very easily break the whole website completely. And when that happens, just restart the Docker. Oh yeah, the DB is not defined. So I just restart everything. I got DB there, and DB is not defined. What? Oh, let's store it in the app. So let's do app.db equal to something like that. Okay, let's hook everything. I can remove that. So it's hooked again. This time, if I try to save, I still got an error, and the error is app is not defined. Okay. Yeah, because like I said earlier, like this code replaced the original function, but because it's running in a different context, I don't have access to the thing outside of it. So I will just import the app here. Import current app as app. And now I should be able to get access to it. So I need to restart everything again because I broke the website. I hook, oh, it's hooked now. And if I run, still got an error. Original is not defined. Okay, let's do something. Let's wrap everything inside a function. This is just to avoid all the issue of undefined stuff. I will just wrap everything inside of this, and I will call this function. Up, here, okay, I can just restart that. App is not defined. Oh. Okay, now it should be good. If I try to save, no, okay, so I can save my secret. But actually my malicious code should have been running inside of the original one. So now I will try to do a curl request. So curl, what's the website name again? Is this one? Slash, so it's this one, and the URL is api.save. So this, we want some data, and in the data we want it's JSON data, and we said if there is hack, it will reply with our thing. So reply hack. We don't really care what's inside of it, and h content type application / JSON. So here I do the request again, and now I got access to the secret from other users. And this is just this is just the base 64 of the secret. So now I can have a backdoor installed in the application, but I never touch a single file. So if you are trying to do some blue team or some defense, just monitoring the file is not enough. You can still get completely hacked. But the issue is, because the application is fully encrypted, the secret is still encrypted. I got some base 64 and I cannot read it. It's AES encrypted. So what I really want to do is to inject some malicious code inside the HTML, so I can put an XSS inside the HTML, and with the XSS I can just read the data. So let's do that. So instead of hooking the API function, we're gonna hook the index. So let's look at that. So I can keep my hook over there. I will just don't call this one. Let's make a new one. Okay. Let's look at the name of the function first. So from Flask, we still import the current app as app, and we're gonna print app.view function. I want to know the name of the function. So the name of the function, there is the static, which return all the static files. We have the API save, API contact, and we get the index function. This is the function I want to replace. This is the function that just showed up the page. So I will do the same thing as I did before. But instead of doing all of that, I will do something else. So let's keep a save of this one. Okay, we got a copy just in case. Okay, so my malicious, this time we don't want to do the index.save, we will, the API.save, we want the index, and we will return the original. So, return, make response test, and we will replace the original. So this is the index. Okay. Now if I go to the website, I have the website like working normally, but if I send it to the other screen. But if I run this code, it will, I need to call the wrapper. So this will replace the original with mine, and I will just return test. So let's just see if it works. Now if I try to refresh the website, I just got test. So I replaced the code with that, but this is a bit obvious that the website is broken. This is not what I want to do. Let me just restart everything. So what I will do instead, I will call the original function like I did before. So original with the original args and quargs. So this will be the HTML that will be returned. And what I can do is HTML.replace. I will replace the end of the body tag, for example, with I will just put the same thing, and here I can just add a script. So let's just do an alert one. Okay, and because I don't want to restart my server all the time, I will keep a reference to the original function. So here, when I hook my function, I lose the original one, but I want to keep it for later. So what I will do is we're gonna set attachment of original, So the original is the view function. But if I replace this and I run the code again, this view will be this malicious function. So if get attachment of original, and we'll look at orig. Okay, and I will set here malicious func that's set original. So here I just add the original as an extra parameter to the malicious function, so I can just hook it again, and I won't need to restart all my Docker all the time. This is just because I don't want to do this every time. So yeah, let's try to see if this works. So I run the code, nothing is happening, but if I try to refresh the web page, I got an error. What's the error this time? In replace is not, oh, okay. So this is not, this is a response. So let's just remove that and see if I run this. Okay, so I got my test. And what is inside HTML? I don't know, so let's print, I think it's a response object. If I go there, I should get test again, but if I look at my log, string and line malicious func. Oh yeah, it's HTML dot, what is it again? It's a response object, print the HTML, flush true. Let's hook again, let's refresh and look at the log. So this is my response, and in my response I should have the actual code somewhere. Stream get data. I think this is the function I want to call. So this is the actual HTML code. Let's run again, run the test. Oh. Percent conversion, but the response object. Okay. Why didn't I get the original data? I can. Oh. What is breaking? User exception. Get data. Do I have other thing instead? Oh, it's just .data, I think. Oh, I didn't hook. Refresh. Is everything broken again? What? Make response of test. Let's just restart the. Sorry? No, it won't. You cannot do dash in a function name. Let me just, this is started again. I will hook again here. And if I refresh, I get an error, and the error is implicit sequence conversion, but the response object is in direct path from none. What? And if I just do that, I think I can just cast it as a string and it will be working fine. Response streamed. Is it the? Is this working as I want? Stream response and I don't know why I get this. Anyway, we will do something we'll do it in another way. Original print. So dear. Oh, let's look at the vars. I think we'll get more information this way. What? I think I broke everything again. What did I broke? Oh, I did that data. Okay. And I want to print the vars this time. Okay. And here I should be able to see them. I need to flush. Run that, and I'm fine. Okay. I got the header, the file name. The file name is basically index.html, so I can just read the file and I will replace it. So let's do that. We don't want to call the original again. We just do a copy. So open. Let's read. This is the HTML. Now we can replace the thingy and return original HTML and return the fake HTML. Okay, because the file did not exist. It's in what? Message file directory template. I don't know where is the file. Let's just use our injection to test it. From subprocess import checkout put. Let's command that. Print checkout put ls. And we need the shell is true. And let's just decode it. Decode. Okay, so where is my index.html? Do we have one? Dist. What? Get roots.py. This is the contact, the index. Okay, let's choose the app.py. Path index.html. Okay, it's from dist. So if I look at dist, I should have my index.html, yeah. So dist index.html, I can call this again, command that. So this should work, and now I got access to the page again, but I've added an XSS inside the page. So and I forgot to return the thing. I put my thing is there, and I think I broke something in the conversion because I don't have access to the rest of it. Oh yeah, because I replaced the index. Like if I go to any page now, I think it's broke. But you know, you get the idea. So I will just check if request.path is equal to /, I will do that. Else, I will return the original call with the args and quargs. Hook again, refresh, and I broke. What did I broke? Request is not defined, okay. So the path is not found. Here I got my XSS again, but I got the website working again. So now what I can do is I can just add some JavaScript code that will look at the secret I'm currently typing, and I will be able to steal it. So basically, I just took an RCE that was useless and elevated my RCE to an XSS to get some real impact. So usually it's all the way around when you're doing bug bounty or CTF or penetration testing. You don't want the XSS, you want the RCE. But here the RCE is useless, but the XSS has real value. So everything is reversed. So this is what thing we can do. And we can also create new routes if you want. For example, from Flask, here I can define a completely new thing. So I can do app.root, like let's do /fake, def fake root. That will just return, hello, this is fake. And if I run my code again, I should be able to access the /fake. So I can create completely new backdoors. So what you can do is once you get your first template injection, you can create a new backdoor that will wait for your input, that will evaluate it, give you back the result, and patch the actual template injection so nobody can steal it from you. And this is the kind of stuff I used a lot in CTF. So what I did during template injection CTF, I created a backdoor like this. And every time another team was submitting a payload, I will just look at all the payloads they were submitting. So it was a lot of fun to do, and you can learn a lot from what other teams are doing. But sadly, I didn't find anything as cool as this. Usually the other payloads are more basic. But it is a nice trick. So you can do that in Python because everything is public. And also this is working in Python because the application is basically a single process. And every time you do a request, this process is handling the request. But it's still the same process for every request. If you have an application in PHP, for example, in PHP, it starts a process for every request. So you cannot do stuff like that. But it got me thinking, yes, Python is a pretty popular language in bug bounty, in CTF and stuff like that. But not a lot of websites use Python. There is a lot more websites built in JavaScript and with Node.js. So I say, and Node.js is basically the same thing. You have a single process that is handling all the requests. So I should be able to do something like that also in JavaScript. So let's try to do that. So I got exactly the same website, but this time it's made with JavaScript, with Express and Vue as a templating engine. And I also got the same playground website, so you can do some testing. The same thing happened in JavaScript. You don't have access to anything right here. It's not you don't have access to the process variable. But the thing you can do is just create an empty string or access any variable and look at its constructor. The constructor of a string in JavaScript is the function string. And the constructor of the string function is the function. So you got access to the function. It's a lot of function. But what this function is doing is it takes as a parameter a string and it will create a function with this string. For example, I will just return 42. So this will create the function that will return 42, and I can just call this function. So this is basically eval. And with this, I can just ask to return me process, which is the main object of JavaScript, the reference to the process. And with the process, we got access to require, usually. Process.main module, I think, dot require. Yeah. So we can access to the require function, and with the require, we can import a thing like fs or stuff like that. So let's do that again. We will use the same payload I used before, but this time in my exploit, I will load payload.js, and the exploit, instead of running .py, it will be .js. And let's create a new one. Rename exploit.js. And the template this time is a bit different. So we got the string. We want to do .constructor. Here we will inject our actual payload and we will run it. And instead of doing it like that, let's just do I get access to A to B and B to A? Okay, so what I will do like I did before, a little bit of staging, but instead of submitting in an extra parameter, because in JS, the issue is you don't have nice helpers like current app or the request. You don't have access to that. So I will just put the payload as base 64. So I got no issue with codes and stuff like that. So here I will just return eval and to base 64. It's basically a new buffer with the payload that will be there. Payload, and the buffer is in base 64 to string. Is it okay? Eval new buffer to string. I'm missing something here. Okay, and here I will just replace payload with my payload from base 64 and port B64 encode. Open payload.js.read. Decode. I think this is good. And in the payload.js, I will just try to do like just return 42. If I try to run exploit.js, the byte object is oh yeah. Let's write in bytes. Okay, something went wrong. Why though? This is not required anymore. Let's try something simpler in the beginning. Something went wrong. Why? Oh, because I'm still trying to submit a JS payload to the Flask application. This would be better. Yeah, this is better. So here I can just put that back in. I can run the code. So my guess is the code is running, but I don't have access to the output. And sadly, there is no easy tricks to do to get access to the output. So we are a bit blind here. But the real challenges will be how did I get access to a reference to the Express object, to the server object application. And to do that, we're gonna need to use some JavaScript black magic. Like, to get access to the reference, to this reference, we're gonna use something called async hooks. Let me. What is async hook? So async hook. Oh, I don't have internet. It's okay. Async hooks. What this is? It's an experimental module from Node.js, which allow you to create a hook that will be run every time an async context is created. Let's see if I can. Google.com. Okay, async hooks, Node.js. Oh, I guess someone already visited the website. So this is the async hook module. So this is very low-level stuff. Basically, almost nobody uses this thing in real life. But what we can do is, yes, create a hook, and the hook will be run every time an async context is executed. But async contexts are executed like all the time in JavaScript. For example, every time you do async await, but even a simple console.log is actually an async process. And this is a bit of an issue because that means during your hook, you cannot use console.log because if you use that, it will just basically do an infinite loop because it will create an async process that will be hooked again. So we are still going to use that. And by using that, every time the server receives a request, the request is handled by the socket module, and the socket module uses asynchronous code. So we should be able to get a reference to the application through that. And to do that, I will show you how it works. So first, we're gonna recover the require function. So this function is just in process.main module.require, so I can use it later. I will create my hooks. So how do I create a hook? I need to require, so async hook. This is the module I want. And I will use the function create hooks. Create hook. So create hook take a single parameter which is an object. And this is object. We want to call the function at the initialization of the asynchronous process. So in init, and this function take 4 parameters. We will get access to an async ID, which is unique for each request. We get a type. We got trigger async ID, and we also get access to the resource. So let's write this function. So the thing we want to recover is the app, but we don't have it yet. Luckily, like I told you before, sometimes, every time we get a request, a new async process is created, and I can get access to that using this simple line, which is inside the resource, which is the resource allocated to the async process. If I look at the args, and I look at the first args, and I look at stream, and I look at server.row listeners, and I call this with request, and I look at the first argument, this is the actual node application. How did you find this? By a lot of trial and error. So this I will give you the solution. But what I did is basically I run this async hook. I tried to log what was happening, and because it's too difficult to detect when it's the right async process, I just try that. And if it's fail, I just say okay, no worry, I don't care. I just return if it's not the good thing. I need to put an error. So, okay, so now I got access to my app. And we want to do the same thing we did before with the Python application, which is recovering the list of view function. In Python, it was a dictionary mapping a function name with the actual function. And in JavaScript, it's a bit different. It's an array of function, which will be all called in succession. And once a function is the right one, it will just return the data and stop calling the rest. So, okay, let's create a fake, so our malicious view. So, function malicious. In Express, all the function take 2 parameters, which is the request and the response, usually called just rec and res. And also the next. That means if you don't want to handle the request, we can just call the next function and it will ask the next handler what to do. And here, we can just do a res.send and send our message back. Send hello. Okay, and to use this function, so we can use simply the app.use of Express with our malicious function. The issue is this will be put at the end of all the potential handler, and I don't want that because it will never be run. There is always another function running before. So not a problem. I can just recover this. So If I look at the app, there is an underscore router, and in this router, there is the stack with the list of functions. Let me show you what I mean. Here, on the playground, is it working if I just do like that? No. I should have access to the app. Oh no, no, it's not defined, sadly. So you have to believe me, I will show you later. So there is the router, the stack, and this will be the place where all the functions are. I will just pop the last one, which is my actual function. Why I used app.use? Because there is a lot of internal stuff that Express is doing. I don't want to handle myself. So I just say, okay, use this. I remove it from the back, and I will just put it in the front. So app.router.stack. And I will use a splice to inject it. And I don't want to put it right in the beginning, because in the beginning, there is two handlers that are made by Express, which are just going to parse the request for me, because I don't want to do all the HTTP parsing. I will let Express handle it. So I will just put it at position 2 in the stack. Actually position 3, there is two stuff before. And I will put my layer. And once all of that is done, I can just disable my hooks. Because this will be run at every single async process. So this will basically run maybe 20 times for each request. I don't want that to be running all the time. And now I can just hooks.enable. Enable. So let's go through that again. So this code will be sent to the server. It will register a hook. If the application if we find the request inside the parameter, we store it in the app. Once we get to our app, we can put a malicious functions, and after that, we disable the hook. Okay, and to make things easier, I will do rest.send, this should be fine. Oh, let's try to run that first time. So if we have that, that means now every request will just send hello and the website will be basically broken, but it's fine. There is like 100% chance it's not working on the first try, but exploit JS. I got the same issue as before. What is happening with? I don't get what's happening with my Python code. Let's okay, it says something went wrong. Why? Luckily, I got a copy of that. I can just copy past this. Let's see if I get more information. Return 33. Ultimate. This is not my code. Is this the right one? Hooks enable. Process. Okay, what is not working properly? I think it's something inside of this. So constructor.constructor return eval of new buffer base 64. They forgot something. I don't have the error. Let's try to do that in. Let's print the actual payload. So this should be running, and it's not. In the playground. Cannot find module async hook because it's async hooks. My guess is, yeah, it's async hooks. Okay, payload.js async hooks. So let's run that again. An email was sent to the admin, but now every time I open the website, I should have broken the website, and I got hello instead. So I was able to get a reference to the express object and replace the thing in memory again. Okay, and now we have that, so this broke everything, so I need to restart it. I want to do like the same thing as before. So instead of just sending hello, we can check at the request. So if the request.path is the path we want, so if it's the index, we will do something. We will do something else. Okay, I will once again read the index.html. So if I want to run some code, some command, I can require child process. Here I will remove that. And cp.exec_sync id. And we just rest.send and execute that. So I send my first request. Everything is working. It's install all my hook, recover the app, and put the fake root in the fake thing, the malicious function. And if I call the thing again, this time it will just exec my code, and I get here exec nobody group, etc. So now every time I go to the website, I got this again. Oh, it just sent me bytes. So my browser tried to download it, but it's the same thing. Okay, and now we can do what we did before, which is let's get fs this time, and you do fs with file sync. It was in this index.html. If I do that, I should so if rec.path. If it's not slash, let's just do the next thing. Let's just ignore the request. And if it's slash, we will get index.html, and we will replace what we did before, body with script alert. This should be okay. I can just remove this. I don't need it anymore. Let's run that. An email was sent to the admin, And if I go to the index, with file sync, that replace is not a function. What is it? Oh, this should be, it's downloading something. Let's curl the page to see what's actually happening. I think I broke the content type. Oh, this is okay, so toString. I think it's just a byte buffer instead of classic string. Okay, so it's run. Oh, I don't want this, I want this. And if I curl, I should see my alert one, yeah. Not this one, and this one. So I got my alerts, but the website is still working. So once again, I managed to backdoor the application without actually touching a single file on the whole Docker. And that's basically all I wanted to show you today. So if you got any question, if you want me to go back on some specific points to help you understand it better, I don't know. Do anyone has any question about all of that? Yeah. No. So thank you, everyone. If there is a, oh yeah.
Will we be able to access your exploit scripts after this workshop?
They're not released yet. I'm planning to do a blog post about all of that. It should be released, like, I think next week or in 2 weeks. But you can still download all the Dockers from the website earlier. On bi.tk/docker. Compose the channel, so it should be in lower score. So here you have the Docker if you want to train.
Okay, thank you. I'll be looking forward to the blog post.
Sorry? Yeah, and I will share everything. But I can show you something else if I have it over there. Okay, so I will show you a tool I built with will be available also in 2 weeks that do all of this, but automatically. I'm just building the application. Just give me a sec. It's a bit slow. Yeah, it will be on Twitter. You can follow me at BitK. Or on the YesWeHack Twitter also. It will be probably on the YesWeHack blog. So you can find me over there. Let's open this. So this is a tool I built to automate this kind of attacks. I can just grab a payload from here. I will do it on Flask. I want a Jinja SSTI payload. It will just build a payload for me. I can copy paste it, and run it. I will run it here, for example. So nothing happened, but basically what it did, it installed in memory a parasite, a malicious agent, and now I can see all the actual root of the website. I can even check the source code directly from my backdoor. I have a nice shell ready, which run the code remotely. I can also look at the file system directly, so I can see everything that's inside the target. But another nice thing is you can easily hook roots. For example, here I call the original function, but I can just say, okay, return from Flask import make response. Hello, and I want to hook the index. I will try to hook it, it's turned to green. And if I try now to go to the index, I should have hello. And I can also just say, okay, I don't want to hook it anymore. I can unhook the root, go back, and everything is working just like before. So I plan also to share this tool. My boss don't want me to share it because he think it's maybe too dangerous, but I will try to share it with you. So this will be also another way to use this kind of technique during one of your pen tests. But also, if you find a template injection in real life during a bug bounty or pen test, make sure you have the permission to do this kind of attacks, because this can be very destructive. Like I showed you before, I crashed my own website maybe 10 times today, even more. So it will happen to you. If you do it in production, it's going to be bad because you need to restart everything. And sometimes it's not easy to restart the server. And also you can think of it, it's the same. If you are doing a pen test, you will never put a backdoor in a PHP file, for example. Think of it as the same thing. So don't do this in production if you don't have the authorization. This was all an exercise to understand better, like, okay, if I get RC in a Docker, is it still an impactful vulnerability or no? And with this, I just proved that it's still a big impact, even if everything is read-only. So that's all I had to say today, I think.
Actually, we have another question from the Slido. Yeah. If you had access to the file system, couldn't you just plant an agent onto the server?
No, because the whole Docker is mounted in read-only. So I cannot write on the server. And another thing is, in Docker, if this is a Python application or a JavaScript application, you need to restart the process for the modification on the file to work, actually. But if you will stop the process in the Docker, it just stops the Docker. So there is no way to restart the process. So no, accessing the file system is not doable in this case.
Okay, then do we have any more questions from the floor? Okay, if not, let's give a round of applause for Lucas here. Yeah.